Good day students, welcome to Kukreja classes. Today we will learn about bases and their properties as well as pH and its importance, as well as we will learn about universal indicator. So before starting we have some questions like, have you ever touched soap? How does it feel? It feels soapy to you. Uh, the soapiness and the soapy feel you which feel is due to the presence of base, sodium hydroxide in it. So this is the importance of the base here. So the second question is, why is toothpaste why we use toothpaste before brushing? And the toothpaste has the base in it. So when we eat sugar substances, then the bacteria present in mouth breaks down sugar into the acids. When the pH of the acid goes down below the certain limits, then it causes the tooth decay. To prevent the tooth decay, we use the toothpaste contain bases which neutralize acid. So it helps in, you can say, preventing the tooth decay. The third question is, why do detergent remove grease? Because the detergent contains some alkalis which help in removing the grease from the clouds. So that's why here so this is the importance of alkalis here. Alkalis actually are the water soluble bases. They are bases, but water soluble bases are called alkalis. So so we use alkalis in most of the cases when we refer bases, because most of the reaction take place in aqueous solutions. That's why both words are used there. Now we come to the properties of the bases. So we know that bases are bitter in taste and soapy in touch. They turn red litmus blue. They conduct electricity. They react with salt to form. They react with acid to form salt and water. They react with acid to form salt and water. And moreover, if we go for the uses of the bases, they are used in making the soaps, detergent, so like that, and like sodium bicarbonate, baking soda. So you see and magnesium hydroxide, which we used to prevent the acidity in the stomach. So these are some uses of the bases. So if now we go for the pH, the pure water. If we pure water has the equal, you can say, the equal concentration of hydrogen ions and the hydroxyl ion or hydroxide ion in it. So when we add acid in the water, then there is an increase of H positive ions in the solution. So that makes the solution more acidic. Similarly, when we add base to the pure water, then the hydroxide ion concentration in the solution increases, and that makes the solution more basic. So there was a Danish chemist, Sorensen, who devised the pH scale on which the strength of acidic and basic solution can be represented on the basis of the hydrogen ion concentration present in acid and basic solution. Sorensen linked the hydrogen ion concentration of the acid and basic solution to the common numbers from 0 to 14. So the acids, so pH is generally defined as it's inversely proportional to the hydrogen ion concentration. pH, in which the P stand for potential, means power, and H stand for the hydrogen ion concentration. So later on, if the pH of the water, if it is a 7, and if the pH of any solution is below 7, then it is a acidic, and if the pH of the solution is more than 7, it is a basic in nature. So this is how we define pH scale. If further we go for the universal indicator, so before starting with universal indicator, I will tell the importance of pH. So the importance of pH is because you know that in our body the stomach produces acid. So the acid has some pH of 1 point something, so 1.4. So to